LM spend rarely explodes all at once. More often, it leaks through bloated prompts, long outputs, retries, duplicate work, and weak attribution. Before optimizing architecture, we need to see where tokens become cost and why margins can quietly disappear. A simple LLM demo can look successful while hiding production risks. Direct provider calls, limited monitoring, weak fallbacks, and no real cost controls. We'll start with one of the earliest warning signs: token spend. Long prompts, verbose answers, retries, and repeated context can turn normal usage into a reliability, quality, and margin problem. Token cost usually grows through repeated ordinary choices, not one dramatic mistake. Each request includes input tokens from the prompt, context, and retrieved data, plus output tokens from the model's response. When prompts expand, completions run long, or failed calls are retried, the bill multiplies at scale. The bigger risk is weak attribution. Without tracking spend by feature, tenant, and workflow, expensive usage stays hidden inside aggregate traffic, and cost can grow faster than revenue. Every LLM call has two metered sides: what you send in and what the model sends back. Input tokens include more than the user's question. They can include system instructions, chat history, retrieved documents, and tool schemas. Output tokens include the answer, along with formatting, structured fields, and any extra generated text. Pricing then depends on the model tier, with larger models usually costing more, especially for output. Retries and high request volume repeat the charge. Cost control starts with trimming context, choosing the smallest capable model, limiting verbosity, and avoiding unnecessary calls. Prompt bloat is technical debt hidden inside every request. A system prompt starts small. Then teams add policies, formatting rules, examples, and extra context just in case. Each addition seems harmless, but across thousands of calls, it multiplies input tokens and cost. Treat prompts like production code. Version them, review changes, and set clear token budgets. RAG is meant to improve answers by grounding the model in retrieved knowledge. But when retrieval returns large chunks, too many results, or loosely related documents, the prompt becomes expensive without becoming better. Those tokens are paid for every time, even when they do not improve the answer. In chat workflows, the cost grows further when the same retrieved context is resent across turns. The goal is not maximum context, it is relevance density. Fewer chunks, better ranking, less duplication, and context that earns its place. In a chat app, the user's latest message may be only a small part of the next prompt. The system might replay conversation history, add retrieved documents again, include tool results, or pass old logs back to the model. That repeated context injection compounds token usage, so cost and latency rise turn by turn. Instead of remembering everything verbatim, use rolling windows, summaries, and clear memory policies to keep what is useful for the next response and remove what is duplicated or irrelevant. A prompt budget makes token usage an engineering decision, not a billing surprise. Start by separating request types, because chat, summarization, extraction, and support flows need different amounts of context. Reserve space for what must vary, user input, and the most relevant evidence. Everything else should earn its place. Repeated policies, verbose examples, and stale history should be compressed or removed. Version prompts the way you version code, so when cost or latency jumps, you can identify the change and decide whether the added tokens improved quality enough to justify them. Completion length is one of the easiest cost levers to miss. If you do not set max tokens, or if you ask the model to explain in detail, it may generate far beyond what the user actually needs. Every extra output token adds cost, and often latency, because the response must be produced and streamed. The fix is to define the right response shape: a summary, bullets, JSON, or a strict token cap. Match completion length to the product experience, not the model's natural verbosity. Output governance gives the model a clear contract before it starts writing. A vague prompt invites long explanations and higher completion cost. A governed prompt defines what good looks like: 3 bullets, a JSON structure, or a 100-word cap. The point is not to make every answer as short as possible. Use examples of concise, high-quality responses, then measure both savings and usefulness. If quality drops, the contract is too tight. The goal is focused output, not starved output. Retries are useful, but with LLMs they are not free. A timeout does not always mean the first request failed. It may still be running at the provider, generating output tokens and a bill. If the application immediately sends the same prompt again, you may pay for both calls and receive two different completions. During provider slowdowns, aggressive retries can also add traffic to an already degraded system. Safer designs use idempotency keys, retry budgets, backoff, and clear timeout handling, so recovery does not become a cost multiplier. A retry should be a controlled decision, not just try again. Each logical request needs an idempotency key, so repeated attempts are recognized as the same operation rather than a new charge or action. Then classify the failure. Timeouts, rate limits, and transient server errors may be retriable. Validation failures usually are not. Apply a retry budget with exponential backoff, so pressure decreases instead of amplifying an outage. If a request already completed, return the cached response when appropriate. Safe retries improve resilience while preserving correctness. Aggregate LLM bills are almost useless for optimization. Every request should carry business tags: tenant, feature, request type, model, prompt version, and environment. These tags turn token usage into an attribution model. You can see whether chat, search, support, summarization, or extraction is driving spend, and which customers are responsible. The key comparison is cost versus value. If a tenant's LLM cost is out of line with contract value or tier, you have an action path: cache repeated work, route to cheaper models, shorten prompts, or adjust pricing before margins disappear. Token metrics become powerful when they connect to unit economics. Instead of asking how many tokens did we use, ask what does this workflow cost to deliver and does the revenue cover it? Track cost per request, successful task, active user, and tenant. Compare margins across workflows, segments, and tiers. This shows where one feature is healthy, another needs caching or a cheaper model, and one tenant may be unprofitable. Also, watch for regressions after prompt changes, model upgrades, or traffic shifts. These numbers should guide packaging, rate limits, caching, pricing, and model selection. The main lesson is simple. Runaway token spend is rarely just a billing problem. It usually exposes design gaps: bloated prompts, oversized context, verbose outputs, repeated work, and uncontrolled retries. Production teams need budgets, governance, deduplication, attribution, and unit economics tied to features, tenants, request types, and business value. Next, we'll connect these cost signals to reliability, infrastructure, and model quality failures.